Hello, how are you? I hope you are doing well. This time we will explain how to calculate intrinsic reaction coordinates IRC in games. This tutorial is a continuation of a previous one in which we explain how to calculate the transition state using the games program. If you haven't seen it yet, I suggest you check it out, as we will be using the structure resulting from the transition state calculated in this tutorial. To calculate the IRC, we will use the following computer resources available for free on the web. The first is the molecular viewer program WX-MAC-MOL-PLT, which will allow us to visualize the resulting structures and perform different analyses of the geometry of such structures. We will also use the computational services of the chemcompute.org website that will allow us to perform the corresponding quantum mechanical calculations. We will also use the webmo.net website to perform the Hessian matrix calculation, as this information is not available on the chemcompute.org website. Now we will begin the explanation of the procedure used to calculate the IRC using the games program. We enter the website chemcompute.org. Then select Games. Submit a job. Then submit your own file. Select your file, and press the Submit button. We are going to perform the same SAD point calculation that was done in the previous video, in which we explain how to calculate the SAD point of a reaction mechanism. Please wait while the calculations are performed. If the calculation is successful, you will receive the message, "Execution of games terminated normally." Once the calculation is finished, we proceed to download the output file with the results. We move the downloaded output file to our project folder and rename it. We open this output file with the MAC-MOL-PLT application to visualize the structure obtained. Here we can get information about the geometry calculated for the transition state. Now we will copy the coordinates of the atoms corresponding to the structure of the transition state to use it in the calculation of intrinsic reaction coordinates IRC. We replace the coordinates of the transition state calculated in the initial input file used in the previous section. Save this file with a new name. Remember to add the INP extension to this file. To perform the IRC calculation, it is necessary to read the Hessian matrix, so we must include this information in our input file. Since Hessian matrix information is not available on the chemcompute.org platform, we will use the webmo.net website instead. A disadvantage of this site is the limitation in the calculation time. We access the webmo.net website and register with the username guest and the password guest. In the menu bar, we select New Job and then Execute Input File. We give our job a name and open our previously edited input file. Then we press Execute Job. Let's wait until the job finishes running. Even if the failed message appears, we can still get the calculated Hessian matrix since our TS structure was already optimized. Press the View Results icon and then select All Files. Once the window is displayed, look for the file output.dat. This file contains the Hessian matrix data. Go to the bottom of this file and search from bottom to top the group named Hess. Select the information from the Hessian matrix until you find the end of the group. Press Ctrl+C. Open the file containing the transition state data and paste the Hessian matrix information into it after the coordinate group. Delete the previously used commands and replace them with those corresponding to the IRC calculation. For the IRC calculation, we will use the following parameters. Endpoints equals 100. That is the number of points to be calculated. Saddle equals true, because we are starting with the saddle point. SenG equals true tells games to recompute the energy of the TS. Forward equals true. Indicates that the path is in the forward direction. Set to false indicates that it will be in reverse. The displaced geometry will have a non-zero gradient, the negative of which points downhill. The geometry is displaced in this direction, the gradient is recomputed. And the procedure is repeated. Endpoint equals 100 times or until the root mean square of the gradient is below optal equals 0.0005 atomic units, at which point you are at a minimum. Stride equals 0.1 tells games how far along the gradient it should displace at each step. In this case 0.1 atomic units. Save this file with a new name and the INP extension. First we will run this job with forward set to false, that means in reverse direction. We run this job in the chemcompute.org platform. We download the output file, move it to our project folder and change the name to IRC Reverse. Now we change the command forward equals true and run the job again. This will perform the calculation in the forward direction. Save the file. Upload this input file to chemcompute.org website and run the job. Once the calculation is complete, download the output file. Move this file to the project folder. Change the name of this file to IRC Forward. Open the IRC Forward output file with the WXMac mol PLT program. Now we must add the frames corresponding to the reverse direction. Check the box "Make this points negative" so that the points are plotted in reverse order. Moving this bar from left to right, we can visualize the displacement of the atoms in each step of the proposed mechanism. Now we can visualize the energy profile for this reaction pathway. In the menu bar we select Subwindow and then Energy Plot. In this graph all the calculated points are displayed, and by pressing on them we can visualize the corresponding structure and its energy. We appreciate your attention and we hope it will be very helpful to you. Thank you very much and see you soon with another interesting tutorial.